Hello, my name is Peter Waugh. I am the principal engineer at Engineers Without Borders USA, and this is the webinar for assessment activities for structural projects. And we like to start out all our webinars just reminding ourselves of our mission and vision, and reminding ourselves that really the reason we're doing what we're doing and the reason we're doing this webinar is to assist you, your chapter, to help your community with their structural engineering projects. Just real quickly, an introduction. The purpose is to provide guidance for chapters that are planning an assessment trip for a structural project. Truth be told, though, I mean, you could view this at any point during a structural project, and it would likely still help you out, even if you are at the design phase or getting ready for implementation. The intended audience is any chapter member that's going to be part of a structural project. And then just a couple limitations we have. This webinar is specifically for buildings. We don't talk about bridges or water tanks. Nevertheless, some of the things you learn in here would be appropriate for bridges or for civil structures. And then secondly, this trip doesn't cover the activities that you will cover on your initial assessment trip to the community. So this does not go over the, working with the community and finding out what they need, etc. That's all covered in your first assessment trip, and we have another webinar that talks about that information. This really is specifically for your second assessment trip to the site, or maybe it's after that, where you're assessing specifically for the information you need for a structural design. And then hopefully after learning, after viewing this webinar, you're going to have a much better idea of what to do on your assessment trip. And then I have just a few photos here, just kind of typical structures that have been done by EWB USA chapters, just to give an idea of kind of the scope and magnitude of the type of structures that are typical for an EWB USA project. And let me now just go through a quick outline of our presentation. Firstly, I'll talk about how to develop your assessment plan. And then after that, the specific things that you're going to need to find out during your assessment. What is the need and priority of the project, verifying the ownership and usage of the building, collecting data to allow site planning, and then starting to get into some of the stuff for the building itself, space and architectural planning, learn about local practice, determine what your governing design criteria would be, how to assess material properties that will be used in your implementation. Then we'll talk about what typical tasks you'll carry out at the site, and then lastly, just how to check the assessment plan that you've put together. So developing your assessment plan, what I counsel chapters to do is always to start with the end in mind and work backwards. So the end, what you want out of your design is a final design and pre-implementation report, and that includes calculations, drawings, and a construction plan that will do two things, well, actually three things. First of all, it's going to be approved by our technical advisory committee. Secondly, it's going to allow for implementation in the field with your partner community. And lastly, it's going to result in a sustainable, well-used structure for your partner community. So that's the end. Taking a step back from there, you just think, okay, well, what data then do I need to collect in order to allow my chapter to produce that final design? And then taking a step back from that, you know what data you need. Okay, what assessment activities do I need to carry out in order to collect that data? So starting out, I mean, really, the first thing to verify is that there is a need and priority for this structure. During your first assessment trip, you determined that your partner community wanted assistance designing a structure. The first thing to do, and it should be a no-brainer, but it can be sometimes that communities change their minds. So the first thing you want to do is confirm that, yes, the structure is still kind of first priority for the community, and that it's a high priority for the whole community, not just a select group within the community. So that shouldn't take you that long. You figured that out on your first assessment trip. Just verify it on your second one. And then after that, also determine with your community what is your role in this endeavor. Sometimes really it comes down to the only thing the community really wants from you is funding. They're perfectly capable of designing and building the structure on their own. And if the only thing you bring to the table is money, then this is probably not the right project, because we're an engineering organization, or that's what we strive to be, and we're not in the business just of fundraising for communities. So really, you should be there to do the design and implementation, and if some fundraising comes with that, then so be it. Ownership and use, very important. You must have concrete proof that the land is owned by your partner community, or that they have some kind of permanent easement to use the land. I mean, the last thing you want to do is build on someone else's property. This hasn't been an issue, actually, historically with structures, though it has been, in a couple cases, actually, for wells, where chapters constructed a well on what they thought was community property, but it wasn't, and then all of a sudden there was a lot of difficulty using it after it had been built. So just make sure the land ownership is taken care of. Make sure the building ownership is taken care of. I mean, it should be owned by the community, not by like an individual or a select group of people. And then very importantly, building a building is not the end goal for the community. What they want is the building to facilitate something, to facilitate, kids learning something as a school, or people getting medical care as a clinic. So make sure that the community has a concrete plan for use of the building, and that they have funding for that plan. So what we don't want is you to go to the site and figure, oh, well, this community needs a school, so we'll build a school. If they don't have funding for teachers to man that school, then it's not going to be a sustainable project. Even if you get a building built, it's not a sustainable project because they don't have the funding for ongoing operation of that facility that you built with them. So very important, make sure there's a plan and funding for that plan. So the first thing you're going to want to do, and most professional members of EWB kind of already know this. Many student chapter members don't know this because a lot of times it's not really taught in school. I mean, really the first thing you have to do is some site planning. You can't design and build a building in divorced from the rest of the world. You have, the first thing you have to do is figure out the site, and the community is going to know where they want it, most likely. And you're going to have to assess that, make sure it's a good site, and then propose alternate sites if that site is found to be inappropriate. You're going to want to put together a surveyed site plan with topography and man-made and natural features in the vicinity of the proposed building. So if there's a ravine really close to the proposed site, that could be a significant limitation to the construction of the building or the safety of kids, say, if this was a school. And so you're gonna need to show that on your site plan. If you're at the bottom of a steep slope, say in Guatemala, where there's landslides on a regular basis, you want to show that. But you'll also want to show the topography, show the roadways, all that. So get a surveyed site plan of the building site. Do a geotechnical site characterization sufficient to determine soil properties that are going to affect the foundation design. And so you're not going to need to do as much soil characterization as you would here in the United States, but you have to do enough to know generally what kind of soil am I dealing with and what are its characteristics. And then lastly, a hazard characterization. And the two things that most commonly affect potential building sites would be look at it for flooding considerations, is it prone to flooding, or geotechnical considerations, is it potential on a landslide slope. So after the site planning, you're going to want to do space planning. In this, you'll do a couple ways. One is you'll look at other buildings in the area to see what the common practice is, and then also you'll talk with your community. And I'm not going to go over all these items on here, but basically, the uses for the building, how many people are going to use it, how often they're going to use it, what kind of individuals will be there, electricity, plumbing, lighting, ventilation, all that. You have to get what the norm is for the area you're working with. Here in the United States, having a building for public access that doesn't have plumbing, I mean, you just never do that. In some areas where we work, that's common practice. There's an external outhouse and an external place to wash your hands, and there's no plumbing indoors. But just make sure that you know what is the norm where you're working. And then you're going to want to spend a lot of time at the site looking at what is the norm for building types. So you'll take photos, you'll take measurements, you'll take a lot of notes, just so that when you get back and are designing this, you don't inadvertently design something that, while it may be perfectly appropriate here in the States, you take it over there and it just seems ridiculous to your community members because it just is not within the norm at all and wouldn't be useful over there. You'll want to know what the construction materials are, so you'll take a real close look at that. Uh, and then what are the construction practices? You know, if possible, go to a couple construction sites and take a look at the buildings as they're being built so you can see how is this done and incorporate that most likely into the work that you're doing. And then what available equipment is there for doing this? You know, it's not like you can always order a crane. How a big thing is, how are you going to mix concrete? You're most likely not going to get a ready mix truck to your site, but can you rent a small mixer, or are you just going to be doing it on the ground using a volcano method? And then what is the availability of skilled and unskilled labor? So all this you'll take into account, you'll learn at the site and take into account as you're doing your design. So let me now just show a couple of photographs. I took these at a site in Uganda. Actually, it was not a building project I was working on. I was working on a rainwater catchment project, but there were a couple buildings being built, and it was interesting to see what the norm was at this site. So the norm for buildings was that every individual actually built his own building. You didn't hire a contractor to do it. And the vast majority of the materials were also fabricated by the individual. These bricks were actually fabricated by that individual standing there. And one thing that was interesting there is the masonry. There was such a wide variation in the size of the masonry that there was a huge amount of mortar between the bricks, much more than here in the United States. Here in the United States, you've got about a 1/4 inch of mortar, or is it an eighth? I forget. About a 1/4 inch of mortar between bricks. There you have, you know, up to 2 inches between bricks. So it's an entirely different methodology for doing a brick wall. And then also for the roof in this area, both the construction of the roof and the design of the roof were very different than you would have here in the United States. They just found these local poles, and they, you know, there's a tree, that type of tree in the area that provided these poles, and this is what they would use, and then they would climb up there and build it in this method. And clearly, I mean, we would, as if we ever built these, we would not climb up that way just because it's not safe, but that was the norm in the area. It was just interesting to find that out. And then as the whole building was finished, this was actually another building, but as it's finished off, you know, I got the idea of how the roof sheathing is connected to the purlin. The purlin is connected to this roof rafter, and that is set into the brick wall that's been mortared over. So you get all this information, and if you have some photos, then you get back to your you know, where you do the design, and you kind of, it all makes sense then, and you can design something that fits exactly with what the local practice is. One thing you're going to want to do is find out what the design criteria are. You know, there are some countries that actually have pretty good national design codes. Ethiopia, for example, has a fairly good code. There's other countries that don't really have much of a design code, and so there's not much there. I mean, if there's a national design code, you'll want to use that. If not, just go ahead and default to the International Building Code. One thing that throws a lot of chapters is getting the loading data for wind and seismic loads. So seismic earth movement is actually not that hard. If you just go to the U.S. Geological Survey, their website, and type in something to the effect of international seismic movement or something like that, there's mapping for the entire world for seismic movement. So you can get that. I've had more difficulty actually with wind loadings, and there it's more difficult. Generally, it's on a country by country basis, and you have to somehow find, either through local engineers or local government sources, find what the governing wind loading is, or wind speed for design in that country. Material properties are actually one of the areas that's going to be quite different from here in the United States. You know, here in the U.S., you can specify concrete strength. That's what you'll get generally. You can specify the strength of rebar you want. You know exactly what kind of wood you're getting, etc. That is not the case where you're going. So you are going to have to figure out what the actual material properties are. You can't just use typical values for here in the U.S. So you may need to bring back samples for testing in the U.S. or find testing materials in country. And then, you know, hopefully you'll get some recommendations from your local partners, the community or an NGO, about in-country suppliers, and you'll go there and find what their what's available. And say for reinforcing bar, you may even want to buy a length of it, have them cut it into, you know, specimens that you can bring back to the States and go ahead and test them here. So, but just some details. Reinforcing bar, you should assume you're going to get 40 KSI steel at best. You may even get something worse than that. So here in the U.S., generally you always get the 60 KSI for reinforcing bar. Overseas, a lot of times you get 40 KSI, or I've been in countries where, like in Guatemala, they reference something like Comercial, which was even poorer quality. So get some specimens, bring them back and test them. For wood, either use very conservative values or bring back some samples to test. And also, if you use a lot of wood, you're going to have somebody during the implementation who knows how to grade wood, because you're not going to get the grading that you would here in the United States. You know, you get, say, a beam with a huge knot hole in it that makes it essentially unusable, along with some really good materials, whereas here in the United States, that would have been graded out. Concrete, you know, either cast test cylinders of your proposed mix, or if you're not doing that, just use 1,500 PSI for hand mixed concrete or 2,500 PSI for machine mixed concrete. And then again, just some photographs that show the kind of the variation in materials that you'll get. That house I showed you earlier with those large bricks, this is actually how they make the bricks in this area, you know, just in the middle of their banana, you know, little field there. They get an area, they make their own bricks, and then they fire them themselves just by starting a fire in there. This is what it looks like after it's been fired and the mud comes off. So clearly there's not the same quality control that you would have here in the United States. So you have to use a lot more discretion about use of materials than you would here in the United States. This photograph, I guess most civil engineers with some experience would look at this and maybe say, oh, that's some unclassified fill material. Actually, it's not. Surprise. It is what was sent to the site as for use in concrete. They said, oh yeah, this is the aggregate, the coarse aggregate for concrete. Clearly you couldn't use that. You know, we re-sifted it and came out with just the larger material. We sifted out all the small material, got just the larger material. This still would never pass muster here in the United States as material for concrete, but it was the best we could get at the site. So that's what we used at the site for the coarse aggregate for our concrete. And so that's one reason you're going to use a much lower strength normally for concrete than you would here in the U.S. So now let's talk about some typical tasks that you'll carry out at the site to gather this data that we've just been talking about. So you'll have community meetings to discuss the use of the building, the site of the building, the expectations for plumbing, ventilation, etc. You'll visit local material suppliers. Usually what I have seen typically is that these are very small businesses, but they sell, reinforcing bar or cement or stuff like that. It's, much, much smaller than any hardware store you'd see here in the States, but they do supply a fairly wide variety of stuff. You'll have discussions with local contractors about how you go about building stuff and what materials are available, what labor is available. You'll perhaps visit local government officials to see if there's any building permits required. You'll visit local buildings that are similar to your proposed building, to get the construction methodologies. You do a site survey and geotechnical assessment. And then this number 7 is really ideal if at some point you can conduct a design charrette with the community. So this is really a collaborative way of working with the community to together design this structure rather than just gathering information, designing it at your office here in the U.S., sending it back for their review and kind of this back and forth, rather sitting together in one room and working this out. You do need a couple things here. Generally, you need someone who's fairly good at drawing so you can communicate through drawing pretty well. And you have to have the language barrier worked out, either through translation or perhaps you're in a place where a lot of people speak English, or perhaps you're in like a Spanish or French-speaking country where you have a lot of chapter members who can speak the language. But a design charrette is really useful if you can do it. And then lastly, so you've done all this work, you've worked out your assessment plan, this is how you're going to do it. Just go back through and check it. Did you figure out all the activities you need to collect all the data that you need in order to get the design that is going to result in this great structure for you and your community? So thank you very much, and I will, when we're doing this live, I open it up for questions at this point. But if you're viewing this as a recorded session, please feel free to email your project manager at EWB USA if you have any questions about this.